If you've ever heard of the Northern Lights, you can probably picture something similar to this. Also known as the aurora borealis, they appear in the skies of the north as beautiful displays of colorful lights. Seen across skies all over the northern hemisphere, they often are visible in Scandinavian countries and can sometimes appear as low as the upper regions of the United States. People flock from all over the world to view this beautiful and mysterious light show. To most people, these lights seem and look magical. Unfortunately, I'm going to ruin that magic and explain to you how they work through science. To understand how these lights work, we first have to understand how atoms work. As you probably already know, or maybe you don't, atoms are the smallest building blocks of the world. They make up literally everything. An atom is made up of several different parts. We start out with the nucleus, or the center of the atom. Inside the nucleus are the protons and neutrons. Protons and neutrons are two of the three types of something called a subatomic particle. Subatomic particles are what make up atoms. Protons are positively charged particles, and neutrons are neutrally charged particles. Well, they have no charge, they're neutral. In addition to these two, we also have something called an electron, which is negatively charged. The electrons, however, are not located in the nucleus. We can find those in something called the electron cloud outside of the nucleus of the atom. If you couldn't figure this out, these are electrons. The electrons are organized into several different levels. This would be the first level, which holds up to 2 electrons, and if an atom has more than 2 electrons, it would go into the second level. Sorry, my circles aren't very circular. And the second level can hold up to 8 electrons. I'm not going to draw 8, but they're there. Now that we know how atoms are organized, I can start going into how the northern lights work. When a charged particle from the sun, this is the sun, I know, kindergarten style, when a charged particle of the sun hits an atom of our Earth's atmosphere, it does something called exciting it. The electrons of the atom get excited and move up one level. So this electron will go up to the second level. And then, when the electron drops back down to its original level, because it can't stay there forever, drops back down, and it creates this burst of light in a reaction. That's called a photon. Normally, we would never be able to see photons because it's so small, but when we have the millions and millions of atoms in our atmosphere all reacting together, that's when we start to see things like the northern lights. It becomes visible to the naked eye because there's millions of them doing this all at the same time. If you're having trouble picturing this, you can also think of an atom like a sports stadium. Say, the center of the stadium would be the field, and all the players and coaches are going to stay on the field. Unless they've gone crazy and start running in the stands, they're going to stay in the field. The coaches and players would be like the protons and neutrons. They stay in the center of the stadium or of the atom. So this is like the nucleus of the atom. And then we have the fans, the sports fans. They'd be like our electrons. They stay in the bleachers. There's like several levels of bleachers in every stadium, right? So the electrons, or the sports fans, stay in these levels. Then, all of a sudden, a charged particle from the sun comes and hits the atom. Or maybe someone hit a fly ball and it's heading into the crowd, and all the fans want to catch it. So they all run up to the next level. Because, why not? And then, since they have to go back to their seats eventually, they'll wander back down and create a magical burst of light on their way. The photons. So now we know how the lights work, but how do the colors work? As you can see from this picture, or maybe if you knew this already from your prior knowledge, the northern lights show up in a huge array of colors, typically greens, blues, and pinks. Now, the color depends on what kind of atoms are reacting. For example, oxygen atoms tend to produce green lights, and nitrogen atoms produce blues and reds. So there you have it. The northern lights, the most magical natural phenomenon on Earth, explained by science. Sorry if it's not so magical anymore, but at least you learned something new.